Hi everyone, welcome to Brilliant Qatar. Here we have another session for the chapter Chemical Bonding and Molecular Structure. The topic is Octet Rule. Octet Rule refers to the tendency of an atom to prefer to have 8 electrons in their valence shell. Every atom tried to make 8 electron in their valence shell. You know, Lewis and Kossel given this idea about which one? Octet rule and their Lewis dot structure and all. You may studied a basic things in the 10th grade, right? So every atoms try to prefer 8 electron in their valence shell. For example, you consider a species, for example, CH4, you know, methane, right? CH4. If you consider carbon, central atom is carbon. Carbon valence electron, you know how much? 4, right? How we get carbon? You know, carbon atomic number 6. So what is the configuration? 2, 4. So what is the valence electron? 4, right? So carbon contain 4 valence electron. Carbon having 4 valence electron. You know, carbon is tetravalent. Which is the surrounded atom? Hydrogen. You know, hydrogen atomic number is 1. It's having only 1 electron in their outermost shell. So, hydrogen, 1 electron in their outermost shell. Hydrogen, 1 electron in their outermost shell. So, carbon, 4 valence electron. Hydrogen, 1. Each hydrogen, 1 valence electron. Now, as per carbon, how it can complete octet? Carbon already 4 electrons in their valence shell. It needs 4 more electrons to complete their octet, right? So, carbon, it can share these 2 electron, total. Now, on this carbon, total how many electrons are there? 1, 2, 3, 4. 4 bonds are there in which 8 electrons are there. See, 2, 4, 6, 8. Yes, carbon, they completed its what? Octet. So, every atoms prefer to get what? 8 electron in their valence shell, or in their after bonding the element should get 8 electrons. For example, some more detailed explanation we can discuss, that is a Lewis and Kossel explanation. What is the approach to chemical bond formation? Lewis dot structures we studied in 10th grade. Here we are representing only the valence electron on each atom by a dot. For example, hydrogen, you know, hydrogen atomic number 1, it's kind of 1 electron, so valence electron is 1. We can express like this. Hydrogen valence electron 1. Next one, for example, lithium. You know, lithium atomic number 3, right? So 3 means what is the electronic configuration? 2, 1. So what is the valence electron here? 1 valence electron. So we can express lithium 1 electron. Correct? The next one, for example, if you consider, for example, boron. Boron, what is atomic number? 5. What is the configuration? 2, 3. So, what is the valence electron of boron? 3 valence electron. We can express 1, 2, 3. So, careful in mind, that is when you are drawing a Lewis dot structure, all electron in the atom should not represent, only the valence electron you have to represent by a dot, because only the valence electron can take part in bonding. Right. Next one, carbon we already discussed. What about nitrogen? You know, nitrogen atomic number 7, so the configuration is 2, 5. So, what is the valence electron of nitrogen? 5. How to express nitrogen? 1, 2, 3, 4, 5. What about here all oxygen? You know, oxygen atomic number is 8. So, configuration is 2, 6. So, oxygen valence electron 1, 2, 3, 4, 5, 6. 6 valence electron. This is what we call Lewis dot structure. That is the approach to chemical bond formation. Let's discuss in detail. There are some violations. So, already I told you what you mean by octet rule. Every atoms try to get 8 electron in their outermost shell. Therefore, the atoms are take part in reactions, right? So, octet rule, there are some exceptional cases. Let's discuss with some example. These are the 3 main exceptional cases in octet rule. So, here they ask you, since it is MCQ questions are there for your exam, they will give you options and they ask you which is showing an exceptional case in octet rule. rule, or which will show a incomplete octet, which will show a super octet, which will show a odd number of electron the octet violations like that. So octet rule and their violation exception, the exceptional cases are very important. So incomplete octet, this is the first violation of which one? Octet rule. Let's see what it is. Incomplete octet, that means what? Octet doesn't complete it. For example, let's discuss some example for this case, dear all. Very easy topic, carefully remember. BeCl2, beryllium chloride. Beryllium, which is the central atom here, beryllium. You know, hydrogen, helium, lithium, beryllium. Beryllium atomic number 4. So what is electronic configuration? 2, 2. So 2 valence electrons are there. So beryllium valence electron 2. All right. It is surrounded by 2 chlorine atom, right? You know, chlorine atomic number 17. So the configuration is 2, 8, 7. So what is the valence electron of chlorine? 7, right? So let me write 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. So what about beryllium? Dear all, if you see beryllium, as per chlorine, 7 valence electrons already there. It need 1 more electrons to complete their octet, right? So let them share from beryllium. Have you seen chlorine already completed octet? Yes or no? See, chlorine 2, 4, 6, 8. 2, 4, 6, 8. But what about beryllium? See, dear all, beryllium, only 2 bonds are there on beryllium. 2 bonds mean 4 electrons. Have you seen? 2, 4. Is it completed octet? No, beryllium couldn't complete their octet, but chlorine already completed octet. So beryllium is an example what? Incomplete octet. It doesn't complete octet. One more example. BF3, boron with 3 fluorine, which is the central atom, boron. Boron atomic number 5. So configuration is 2, 3. So what is the valence electron? 3. Let me express 1, 2, 3. It is surrounded by 3 fluorine atom. You know, fluorine atomic number 9. 9, what is the configuration? 2, 7. So 7 valence electron already there in fluorine. So it need 1 more electrons to complete octet. So fluorine is okay. Fluorine, they completed its octet. What about boron? Boron, only you can able to see 3 bonds are there. 3 bonds is equal to how many electron? 6 electron. Boron also couldn't complete their octet. So these are incompletion of what? Octet. This is a violation of octet rule. Then superoctet. What do you mean by superoctet? Opposite. Here these examples cannot complete their octet, but here superoctet means central atom possesses more than 8 electron in their outermost. For example, PCl5. Phosphorus with the 5 chlorine. They are all phosphorus. Phosphorus is the central atom. What is the atomic number of phosphorus? 15. So what is the configuration? 2, 8, 5. So phosphorus valence electron is total atomic number of phosphorus is 15. So configuration is 2, 8, 5. So what is the valence electron? 5 valence electrons are there, right? It is surrounded by 5 chlorine atom. 5 chlorine atom. We already discussed. As per 1 chlorine, already 7 valence electrons are there, correct? It need 1 more electrons to complete octet. So chlorine, let them share this electron. So chlorine, all 5 chlorine, they completed their octet. Okay, they are safe. But what about phosphorus? On phosphorus, you can able to see 1, 2, 3, 4, 5. Total 5 bonds are there. 5 bond is equal to 10 electrons. So it is completed, it's having electron more than 8. Is called what? Superoctet. Another example here, I'll make the concept very clear. SF6, which is the central atom, sulfur. Sulfur valence electron is 6. How it is? Sulfur atomic number 16, 1, 6. So what is the configuration? 2, 8, 6. So 6 is the valence electron of sulfur. It is surrounded by 6 fluorine atom. You know, fluorine valence electron is 7. So Each fluorine need 1 electrons to complete their octet. Okay, let them take from sulfur. So fluorine, okay, ready. Let that fluorine already completed their octet. But what about sulfur? Sulfur having 1, 2, 3, 4, 5, 6. 6 bonds are there. 6 bond is equal to how many electrons? 12 electrons. Is it more than 8? Yes, it's called a super octet or expanded octet. Okay, expanded octet. So what is the first violation of Octet rule? Incompletion of octet. Second one, super octet or expansion of octet. The other one, species with odd number of electrons. Odd number of electron. Careful here all. For example, nitrogen, NO. Nitrogen monoxide. If you consider the system NO, nitrogen atomic number 7, configuration 2, 5. So valence electron is what? 5. All right. Oxygen valence electron, you know, 6. Okay, how they can form a bond? If they form a bond, suppose as per oxygen it need 2 more electrons to complete their octet, right? So let them share from nitrogen. So as per oxygen, 2, 4, 6, 8. Yes, oxygen is okay. Oxygen completed octet. What about nitrogen? 2, 4, 6, 7. Have you seen there is an odd electron on nitrogen? So if their system contain odd electron, then they cannot complete their octet. So these are the 3 violations of which one? Octet rule. So dear all, every atoms try to bring 8 electron there in their outermost shell by bonding, maybe by losing electron or maybe by sharing electron, that is through ionic bond, covalent bond or coordinated bond. This is what the chapter we are dealing with, chemical bonding and molecular structure. Hope it's clear what is mean by octet rule. That's given by the Lewis dot structure, Lewis-Kossel explanation and the violations of octet rule. Let's see some other topics in the other session. Thank you all. Bye.